In this video, we are going to be talking about spin triggers, how you can use a HTTP event or a Redis pub sub message as a trigger for your spin app. I will also show you a demo of how you can do these two things as well as combine the two triggers in the same application. Let's dive straight in. A spin trigger essentially maps an event such as a HTTP request to a component that handles that event. Now this is serverless computing, which means everything is event driven. So say a HTTP request comes into your app, you need some code that will respond or do something appropriate for that HTTP event. Now that is the trigger itself. Now as of now, there are two official triggers that Spin supports. One is the HTTP request and two is a Redis message. We will get to both of those in a bit. As of Spin 2.3 and above, an application can support different types of triggers. And at the end of this video, we'll show you a demo of how that works. So let's talk about the HTTP trigger. The HTTP trigger in Spin is essentially a web server. So when an application has a HTTP trigger, Spin listens for any incoming requests, and based on your app manifest or your spin.toml, it routes it to a component which provides an appropriate HTTP response. This is serverless and it's completely event driven, which means that at the end of the day, this is a simple request, do some code, send out a response. Let's take a look at how this would look at in your code. So first, you typically specify a HTTP trigger in your app manifest or your spin.toml. I'm going to create a simple Spin app called Spin Triggers, and I've chosen HTTP as my event trigger and Rust as my programming language. Now, if you open your spin.toml file, you will see by default there is a route and a component that's specified. The route in this case is a wildcard, which means that any incoming request to your application will be routed to the Spin Trigger component. From line 13 onwards, you can see the details of the Spin Trigger component itself. Right now, you don't have to worry too much about it, and let's leave it as the defaults. We can open the lib.rs file to make a small modification and then send an incoming request to this particular Spin app and see your appropriate response. Now let's say we want to add a new component to your Spin app and we want a different route with the same base URL. So let's call this component checkout and say that the HTTP path for this component is /checkout. If you open your spin.toml, you will notice that the details for these components and these routes have been added automatically. You will see that the trigger in this case is HTTP with the route specified as /checkout, which will go to the component checkout. And then from line 24 onwards, you have the details of the component itself. Again, we're going to keep the code fairly straightforward and we'll just change the response to checkout spin triggers, but typically you would do some code before sending a response. Now, when you build your Spin app and you deploy it locally, you will actually see two routes. You will see a default route, which was specified earlier with the wildcard route, and the /checkout route, each of which route to its own components. Again, make a curl request to either route and see the output coming from the respective component. A HTTP route may be exact or it could be a wildcard itself. So an exact route matches only the given route. For example, /checkout will match only /checkout. You can also use wildcards or you can also use pattern matching when it comes to routes. So in this case, we have said we're going to create a new component and we will call it /checkout/admin, which means that this route will go to a separate component only if the exact route is matched. You can use wildcards to match patterns of routes as well. Spin supports two different kinds of wildcards. You have the single segment wildcards and trailing wildcards as well. Check out the documentation for more details on the different types of wildcard and pattern matching you can do with routes. Spin also supports private endpoints. Make sure you're on the latest version of Spin to check out private endpoints where an internal microservice is not exposed to the network. So it does not have an HTTP route and is accessible from only within the application. Now let's talk about the Redis Trigger. Spin has built-in support to create and run applications in response to messages on a pub/sub Redis channel. Essentially, it looks fairly similar to the HTTP trigger, but we're going to make few small modifications so that it responds to messages on a Redis channel. First off, you have to say application.trigger.redis to specify a Redis trigger, and then you can give the address where your local Redis instance is running. I've already set up a Redis instance running on my local machine, which is running on port 6379, and hence the address right there. In this example, any incoming request to the Spin app will map to the component named Redis Trigger. And of course, from line 16 to 21 onwards, you have the Redis Trigger itself actually described. Going to the code, we are going to write simple code, which essentially just echoes the message that has been published on the Redis channel. Super simple. All it does is an echo message. Don't forget to update your cargo.toml to include any crates that you might be referencing in your Rust file itself. So I've created a simple Spin app in Rust. I modified my application manifest, made some small changes in my code, and I've started my Redis server. I'll start my Redis CLI running, and then I can publish a message, in this case hello world, on the channel messages. Now if you go back to your spin.toml, you will see that the channel it's actually responding to is the channel messages, right? It listens in a specific channel, and if you see the integer 1, that means one channel has received that message that it was subscribed to. And if you go back to your Spin app that's running locally, you will actually see the message echoed right there. As of Spin 2.3 onwards, you actually have the ability to have both types of triggers or multiple types of triggers in the same application itself. Just going back to the same example, we have a Redis trigger already. I can add a HTTP trigger too and specify a different component. So I've created a trigger called HTTP, which maps to a component named HTTP. And when I run my Spin app, I can see two routes. I can see a route from Redis, and I can see a route that's serving on local/HTTP. And when I publish a message on Redis, I get the output specifically, which in this case says multi-trigger, and it's listening into that Redis channel. And when I hit the HTTP request, I get a response back from the HTTP trigger as well. There are also community created Spin triggers, such as a trigger for Amazon SQS, a simple queue service, as well as a trigger for MQTT if you're working on IoT. Spin again is open source, so feel free to contribute or even help improve the triggers that are existing for Spin right now. Don't forget to like, share, and subscribe to our YouTube channel for more content on Spin and WebAssembly. Thanks for watching.